Hello, my name is Amin Kishta, and I am a graduate student at Northwestern University. And I'm here to display my machine learning project, and the project title is called Eye Tracker. As the title of the project suggests, I will be tracking eye position. So going through the code, we have this first part of the code, which is basically inputting the video, and then also setting a statement to where at the end of the video to stop the program. Over here, we then identify the region of interest for the video so that we're focused only on the eyes of the video. We then convert the video to a grayscale and then perform a Gaussian blur filter, which will smooth the image and make identifying objects within the video a lot easier with the grayscale and with the filter. Later, we perform this threshold function to make the grayscale either black or white depending on the set threshold. Through trial and error, I found that threshold 20 best works when wanting to identify the pupil since it is the darkest region while excluding all other values. And because the darker pixels will end up being black and the lighter pixels will end up being white, I take the inverse of that so that it's reversed, and then so the pupil will end up being white and the surrounding area will be black, and that just makes it easier when we're trying to find objects. You can then see over here, I find the threshold of the left and right side each individually, and that's going to be important for when I'm counting the number of white pixels using these two functions within each side, and then taking the average, which will give me an idea of when the eye is looking left and when the eye is looking right, or when the eye is looking centered. And that's because the number of, or the amount of white that's being visible in your eye differs from when you're looking in different directions. So once I observe the values of those thresholds, I set this if statement where I noticed when the eye was looking left, values were greater than or equal to 3000. When the eye was centered, values were between 2000 and 3000, and when the eye was looking right, values were below 2000. We then find the contours of the video, which will track the pupil because the pupil is a contour. However, because of noise and other impurities in the video, such as reflection, other contours may be picked up. So over here, we make sure that we sort the contours from largest to smallest and to only display the largest contour, which will obviously be the pupil. And because contours are not perfect ellipses, it'll be difficult to find the center of each contour to identify, an exact position of the pupil. So using this for loop, we'll be making an appropriate rectangle using the dimensions of the contour that it identified. And so it uses the width and height to make the parameters of the rectangle that will perfectly fit the contour. And then using this line, these two lines, and this last one, I'll be making a green line going horizontally down the middle of the rectangle as well as vertically, so that way it makes a crosshair inside the window of the rectangle, and you can see the exact center additionally with this center function, which is just a red dot basically in that place, so you can visually see that. And now over here, this will be the output of the video, and you can see and get a better understanding of how the program works once I play it. So you can see the video, eye is centered, detects it being centered, eyes moves left, detects it as being left, goes back center, and then goes right. You can see what I was mentioning with the contour in the middle being non-perfect, and then the blue rectangle from around it. I can run it one more time to get a better look at it.